day. So if I just go over to here. So the thing is with RCDs, all the other testing that we've done so far has been that we, after a result, either in ohms, low ohms or high ohms, insulation resistance, or we've had a yes and no with the polarity. Now with an RCD, what we're actually going to do is actually get a time in seconds, milliseconds. We want to make sure that the RCD works in the right time frame. So the functional testing. So the operation of the RCD, I've gone through the operation of the RCD with you all before, where we've gone on about the balance, and we've got to make sure that it works and it detects any imbalance in the live and neutral, anything going to earth, and that's set up to a specific figure. So the object of the test is to verify the effectiveness of the residual current device, or RCBO, that it operates at the correct sensitivity. So we're going to send through it with the tester the exact sensitivity, the amount of milliamps that we need to make sure it works, and make sure it works in the right time. So this proves the integrity of the electrical and the mechanical elements. So you can have a standalone device like this, or the video that we're going to look at in a minute is one of the testers that we use at the college. So at the college, we have the big multifunction testers. Unfortunately, I haven't got one with me, but we've got the Q-Techs or we've got the Megas, and they actually do all of these built in. So what we've got is operating times. So this is the maximum operating time that you've got. So down on the left here, so you've got the BS4293 or the BS61008 or the 61009 RCBOs. And they have a maximum operating time, yeah, in milliseconds, or you have a time delay function. And we'll have a look at that. So with additional protection, so where an RCD has a rated operating current, I delta N, not exceeding 30 milliamps, it is used to provide additional protection in the event of the failure of the basic protection or provision of fault protection for careless users. And the operating the device must not exceed, so this is a really important thing to remember if any of you are making notes, 40 milliseconds when subject to 5 times the 1. And I'll go through these tests with you in a second. The maximum test time should not exceed 40 milliseconds unless the protective conductor rises by less than 50 volts. So what we do with these tests, and what this tester does, we go through 6 tests. We test at half the milliamps. So we make sure the tester doesn't work. I know that's really weird, but we make sure that the sensitivity. So if we were testing, which we'll do in the example, at 30 milliamps, we test at 15 milliamps, and the tester does it for us. And we do it, and it makes sure that the tester doesn't trip, because you don't want things tripping if there's something happening. Then we test it at 1 time, so we test it at 30, and then we test it at 5 times. When we do the test, and it's in the handouts, we test it at 0, which is this part of the sine wave, when it's rising, and we test it again at 180, when it's falling. So we test it at these 2 parts to make sure that it's working in both scenarios. And we'll do this when we're doing the example in a minute. So we actually do 6 tests. We do 2 at half, we do 2 at 1, and 2 at 5. And I'll go through the video with you in a minute. And then we do a 7th test. And the 7th test is the test button. The test button is the integral, the inside test device is incorporated in the RCD. This device enables the electrical and mechanical parts of the RCD to be verified by pressing the T or test button. Now, this only tests the inside of the RCD. It does not test the continuity of the earth conductors or the associated circuits, any earth electrodes, or any other means of earthing. Yeah, but we do need to test the test button. So I'm just going to put this little video. I did have it set up earlier, but let's do this and this is a little mega one. So this is the same as the test as we use at the college. It's only 3 minutes long. I like to keep these nice and small and condensed. So if that doesn't work, I have got this video up and running somewhere else.
So let's look at the RCD test functions. You can see you can select straightforward times half, times 1 and times 5 trip currents.
So those are what I was saying to you. So you do 1, half, 1. So you got half here, you do 1 and you do 5. Now, he will go through about an auto test. When we do the testing at college, we do these all manually. But you can do this auto test that he'll describe. And we'll look at ramp testing as well in a minute, which is quite good when we do fault finding. But when we do this at the college, we will do these all individually. So it takes a little bit longer, but still only takes a few minutes.
And by pressing the function key on the front, you can select whether or not you're going to test at 0 or 180 degrees. So
that was the sine wave that I discussed to you, when we just looked at the sine wave. So 0 is on the rise and 180 is on the fall.
Either the rising or falling side of the waveform. Pressing and holding the function key will allow you to cycle through the different types of RCD. Type A, Type AC, or selective, or a variance of any of these.
So what he's showing you is down here at the bottom. So that these things that are moving down here.
Finally, a B-type breaker can be selected. Here we also have the auto test facility where you can dial up the rated value of the RCD, start the auto test, and the unit will run through the whole sequence.
So when he says the rated value of the RCD, what he's referring to is if it's a 30 milliamp RCD. So that's the value of the, the RCD. So that's the ones we use. And as we said, when we looked at this before, the type of breaker.
And then we have the ramp test. This is particularly useful when fault finding because it will prove at exactly what leakage current an RCD will operate or trip. There is also a variable RCD test, which we will look at later. So let's look at the auto test sequence for a 30 milliamp RCD. Pressing the test button, the first test makes sure the RCD doesn't operate with the times half test or half the tripping current. Next, it completes a times 1 test at 0 degrees.
So I'm just going to pause it there and go back for 1 second just to give you a bit more clarity on that. So what it's doing there is testing, and it's saying that it doesn't trip. And it says there over 1,000 because some of these meters have different readings. But what it's saying is it doesn't trip in 2 seconds. Yeah, that's nearly 2,000 or 1.999, but it's 2 seconds. So it sends out that 30 milliamps over here because we can see on the 30 milliamps, it sends out 30 milliamps into the RCD and goes, well, I've done that for 2 seconds and it didn't trip. I'm going to do my next test, but we will do these ourselves or manually.
Next, it completes a times 1 test at 0 degrees.
And so what it's done is at 1 times and it tripped in 30 milliseconds, 30.8 milliseconds. And as you can see, at 0 on the rise.
We reset the RCD and it will repeat the times 1 test at 180 degrees.
So the reason we do it at the college, you've got to reset the RCD each time. So there's no point in really doing the auto test, when we're doing this, because you've got to reset it. So while we're doing this at the college, it's really good for you to learn, as I've always said, about the basics of like the driving test. You wouldn't learn to drive in an automatic. We're going to drive in a manual.
Reset again, and it ups to 5 times the rated tripping current at 0, and finally 5 times at 180. You'll see the display shows end, and then using the function key, you can cycle back through and look at the results.
So what you'll see there is you've got, we should have done it, or we would have done it, 2 at half, 2 at 1, and 2 at 5. So that's 1, 2, 3, 4, 5, 6. There is the 7th test, which hopefully he's going to do now.
Half test, the times 1 at 0 and 180, and then the times 5 at 0 and 180. With the ramp test, again with a standard 30 milliamp RCD, when you initiate the test, the current is ramped up slowly, indicating exactly at what value the RCD operates. You can see here that the RCD tripped at 23 milliamps. The variable RCD...
That test is really good if you're doing fault finding. So you might get called out to some customer's house, or you may go somewhere, and they say that the RCD keeps tripping. Now, what you can do is do this test, and we'll do this when we go into fault finding a lot more, but you do this test to make sure that the RCD is tripping when it should trip. So it's a really good test to prove that either the RCD is working, or RCDs do go faulty. They're like all mechanical things, and it may be that it's tripping when it shouldn't.
RCD test allows you to dial up a non-standard or programmable RCD test current. For example, to test an 80 milliamp RCD, you press the function button to activate the selectable RCD feature, and by pressing the up and down arrows, you can adjust the value to match the RCD to be tested. Press the test button and do a ×1 test, and you can see here the reading is 40.6 milliseconds.
Come out of here, come out of that, bear with me 1 second, and stop presenting, and over here, stop recording.